Niema Moshiri. I've been working with Pavel Pevsner for the past few years, developing online courses. So I'll be talking about how you can incorporate online classes into flipping your own in-person university classes. So first, the motivation of the talk comes from when I was in my own undergraduate genetics class. I entered this room filled with 300 people, and I sat down and was pretty much lost among the masses. And then eventually the lecture started, and the lights dimmed, and two different projector slides were being displayed. On one was the professor's lecture slides, as I was expecting, but then on the other screen, there was the professor's face, which was very weird to me, because usually you don't display a professor in a class where the professor is physically there. So I look up, and the professor's actually not physically in the classroom. And it turns out I was part of the first series of these UCSD linked classroom classes, where they had two lectures going simultaneously, where the professor was actually in one room giving a traditional lecture, and then was being projected into the other room. So I didn't even get to physically see my professor all quarter. So that was interesting. Clearly, it did not feel very good. It felt very much like a dystopian society. And obviously, I did not think that this was the most effective way of teaching. So first, I wanted to see how did we even get into this situation that a university would think this is a good idea. Obviously, we have an increasing number of applicants over the span of the past few years. Anyone that's dealing in academia knows that the number of students coming into campuses is increasing very rapidly. And actually, ironically, the admission rate is declining. So the number of students that are applying versus the number of students that are being admitted is actually descending, even though we're increasing. So to be able to meet the demands of the population, we actually have to increase admission rates, which would make even more of an issue of these massive class sizes. So what can universities do? If you want to maintain the student to professor ratio, either you have to increase the number of professors, or the alternative is you just make these massive classrooms. So it's kind of clear what led universities to get to this point. But in my opinion, I don't think it's a very ideal situation. So what I propose is using technology as a substitute to try to simulate this one-on-one interaction using online courses. So before I talk about how I propose to do this, I want to point out that this actually isn't as far-fetched of an idea as you might think. People have been using technology to replace traditional jobs for pretty much years, right? Centuries now. What I argue is maybe the traditional lecture style one-to-many professor can also be substituted using technology. And to kind of first talk about some arguments people have had when I initially introduced this, one of the first arguments I hear is traditional lectures provide the optimal form of learning. And this is actually just blatantly incorrect. In 1984, Benjamin Bloom actually did a research study where he showed that the one-to-many classroom setting is the least effective out of many different classroom styles that he taught. And the reasoning actually, it's fairly intuitive. He said it makes no sense to expect all students to take the same amount of time to achieve the same objectives. And any of you that have taught a bioinformatics class, I'm sure you directly feel this, where you might have half the class coming from a traditionally biological background and half the class coming from a computational background. And then any lecture style class that you design will have half of your class being bored at some point and the other half being bored at the other point. So this notion of putting everyone into a cookie cutter education clearly shouldn't work, and it's fairly intuitive and it's been proven. So one way that online classes approach this problem is they can modularize each individual component of the class. So if you have students coming from diverse backgrounds, you can have students take as long or as little time as they want on any given subject. Next, people argue that classroom instruction, in difference from Moocs, uniquely personalizes learning. And just the term personalize it felt very ironic to me, because in my own experience, there was absolutely no personal involvement of the professor. So I argue that we aren't getting a personalized class with traditional in-person lectures. And I'm going to argue that we can actually simulate a more personalized class with a Mooc if it's done correctly. And to kind of emphasize the notion that I don't think in-person lectures do a good job of personalizing the classroom, what you end up having is an instructor lecturing to their class for an hour and a half. And then the student usually just kind of nods along and says, oh, that makes sense, that makes sense. And they come home and try to work on the homework assignments, and that's when the student runs into all of their learning issues. They realize I didn't actually understand any of the concepts as well as I expected when I was in the lecture. So the vast minority of the learning experience is actually happening in the classroom, and the majority of it is happening at home independently by the student as they're trying to address their learning breakdowns. And the irony of how a traditional lecture is set up is that the professor is only involved at the surface level education. And the professor is completely void in the entire core learning breakdown addressing step. So with these online classes, I'll show you how we use the professor's expertise to to actually migrate them into the learning breakdown addressing step using the online classes. So the first step towards addressing this issue of personalized classes was what I call the Mooc revolution, where the motivation is pretty much what I've been hinting at. You have some people that see this in-person lecture room and say, I don't really like this. A step in the right direction would be a one-to-few classroom. This is pretty nice. But ideally, in my opinion, a one-on-one interaction with the professor is ideal for the learning experience. Unfortunately, as I mentioned, you can't have one professor for every student. So what these MOOCs tried to do was simulate this using technology. Basically have an instructor-esque computer program teach the student one-on-one. And a massive number of courses, or platforms have come out that have online courses. We use Stepic in our courses. I'll talk about why in a little bit. But yeah, all these platforms came out, and initially there was plenty of backlash against them. And one of the key quotes that I like is, Moshe Vardi, a world-renowned mathematician, said, if I had my wish, I would wave a wand and make MOOCs disappear. And this felt very parallel to what the scholar Johannes Trithemius said in 1492. He said, the printed book is made of paper, and like paper will quickly disappear. So this was right as this new technology of the book came out. And initially, scholars had a lot of backlash because they thought, there's no way that a textbook or some physical book can last and disseminate knowledge. And clearly, he was wrong because we all still have textbooks. So I'm hoping that we can prove Vardi wrong as well and show that MOOCs actually can be a viable alternative. So my goals are to transform the impersonal MOOC into an emulated equivalent of a one-on-one experience with the teacher. So basically design these MOOCs optimally. And second, I want to have students be able to address learning breakdowns even more efficiently than they can with a teacher in a small classroom situation. So what we propose in Pavel's lab is, how can we transition from MOOCs to what we call MAITs? An MAIT, since we love acronyms, it's basically a massive adaptive interactive text. So instead of having this regular MOOC, have a bunch of videos, have students answer quizzes throughout the videos, we've transitioned to this interactive text. And it's basically a textbook where you have a series of information, but unlike a traditional learning experience where you start at the beginning and step by step have these successive learning experiences, in a traditional learning experience, let's say I misunderstood something at this step. Everything else depends on that, so I have some misunderstanding all the way through until the very end of the class. With our interactive texts, if the student makes a given mistake, we have a detour that the student can take that addresses that specific misconception. So the student can then take the detour and then hopefully resolve the learning breakdown using what the professor has, using their expertise, designed to specifically target this learning breakdown. And now hopefully continue the rest of the way. And we have multiple detours for any given step because students might have multiple different learning breakdowns. So why transition to MAITs? We tried in our online classes to do a series of online lecture videos as well as the interactive text just to see what do students prefer. Because we have this conception that interactive texts are better, but students have to be the ones that ultimately say so. And it turns out that students significantly prefer the interactive text to the lecture videos in our online classes. So we have over 200,000 users across the span of our classes. So we have a fairly large sample size, and everyone has been saying interactive texts have been more effective in my learning process than the traditional lecture videos. And Pavel Pevsner has even said, I have not given a course lecture in over 3 years, because his class he teaches as a flipped class where he spent all this time developing the lecture videos, and then he spends all of the in-class time having students bring in their learning breakdowns from watching the videos at home, and he himself can personally help them overcome any specific learning breakdowns, which is a feature that you can't do in a traditional lecture. Right? And in a traditional lecture, you just have to speak to the students the entire time, but this way you can actually discuss with them. And the most important thing, in my opinion, is that it opens student accessibility. So our project has been funded by a Big Data to Knowledge grant, where our goal is to disseminate information as widely spread as possible. And you can have students from all age groups, from various academic backgrounds, from all over the world, enroll in your courses. And the cool thing, in my opinion, is that we even have people that already have jobs in a different discipline migrating into bioinformatics and being able to take these courses that they couldn't do at a university simply because of time restraints. So now that I've given you hopefully a background on massive interactive texts, I want to push for our specific interactive text, the Bioinformatics Algorithms online course series. So we've developed a series of online courses. Some of them focus on teaching you the core algorithms of bioinformatics, and some of them teaching an introduction to bioinformatics to biology students. where these courses were designed using Gagne's 9 events of instruction in mind. So if you're not familiar with this, basically Gagne is an education researcher who has come up with 9 features that any successful course should have. And the first step is you should gain the student's attention. So we have a series of videos and comics that hopefully capture the student and makes them want to ask, what is going to happen in this chapter? I want to keep learning and actually see how this Marty McFly and the doc analogy is going to translate into genome assembly. Then you want to inform the students of the objectives. So each chapter starts with a video where they actually explicitly say, what are we going to learn in this chapter? What are the biological problems? What are the algorithmic techniques? And how will we use them to address the original biological problem? You want to stimulate recall of prior learning by reviewing what the student should have learned before prior to introducing them to new material. Present the content, so obviously we have a series of texts that you present all the content. And then provide learning guidance. This is what I was talking about with our interactive text, where if a student has a misconception, we can actually guide them towards how can they correct their misconception. And then you elicit performance. So within our interactive text, we actually have code challenges integrated directly within the STEPIC platform. So students can learn the content through the reading and then actually solve an online programming assignment directly within their web browser. And provide feedback. We can actually automatically grade their programming assignment and see what specific mistake did they make and hopefully lead them to the correct answer. So in this case, the problem was reverse complement, and I had the student write a dummy answer that has a reverse but no complementing. And we can actually check for that and try to give them hints as to how they can correct what they misconceived. And with this, all of our resources on how do we provide feedback comes from students themselves, where we do surveys seeing what traditional misconceptions did you have throughout the text. What were the common mistakes students made? We can assess performance. So for every given challenge that we have, we can actually see how many students attempted the challenge versus how many students succeeded in the challenge. And this gives us a hint at if we have an extremely low success rate on a given step, maybe something is wrong with how we explained it, or maybe we need more detours to try to help remedy these misconceptions students are having. So it helps us as instructors improve the course iteratively. And since it's online as opposed to a physical textbook, we can make these modifications on the fly. And then enhance retention using analogies. We have analogies throughout the textbook that basically try to bring some abstract concept and introduce it in a way that the student might be familiar with to maybe help retain whatever they're learning. Now, in addition to our online classes that we suggest anyone who's a student who wants to learn bioinformatics take, we want professors to adopt our content into their own in-person lectures. So we have a series of online lecture videos and a series of automatically graded code challenges that have been adopted into universities all over the world. And basically, most of these universities, an instructor will take our videos and then have a flipped classroom setting where the students watch the videos beforehand. Then in class, the professor facilitates some type of discussion or activity among the students where they don't have to worry about teaching the very basic low-level stuff. They can assume students come in with some basic conception of the topics and focus specifically on key areas that students typically make mistakes. And then at home, the students go back and work on these automatically graded coding assignments. So for the instructor, you don't have to put very much effort into your class. You can basically use all of our content that we've spent years and years developing and just plug and play. So some concluding thoughts. I've been personally introduced to this, and I think universities should not move towards these massive one-to-many lecture-style classrooms. And I'm hoping we can use technology to hopefully push students into a situation like this, or like this, where everyone gets their own one-on-one, technologically simulated learning experience. So if you have any questions about our online classes or how you can use our materials completely for free, by the way, in your own lectures, feel free to stop by our booth and feel free to email me or check out our website and ask any questions that you may have. Yeah, thank you.
Thank you very much, Niema. Are there any questions or thoughts? Andrew.
Hi, thanks. Yeah, thanks very much for that talk. Really interesting.
Thank you.
You compared the interactive texts with the online videos, which had no interaction.
Right.
How does it compare to a lecture where there is a person present and therefore is able to kind of assess the mood of the room and is able to see when people aren't quite following along and therefore adjusts on the fly to what they're doing?
So unfortunately, I actually haven't been able to test out a one-to... So what you're describing is more for a one-to-few classroom, where if you have like 20, 30 students, you can have something like that. In my experience at UCSD, all the classrooms have been like 300 plus students, where you can have some question asking, but not very much. So, so I guess the closest thing that I've experienced was in a computer science class on data structures, we had this micro classroom setting where we had TAs have designated little sections across the room, where instead of having a professor be able to talk to all the students, we had a TA designated to talk to the students. And I think that was actually a fairly effective program. We haven't formally tested how it compares to the interactive texts, but it was a step in the right direction. The other problem there, though, is I think that class was 400 students. We had to have like a 20 TA team. Each TA has to get paid 50% time. And it's not as bad as trying to get more professors, but it's still a pretty hefty resource consumption. Yeah. Thank you.
Whenever we have done similar things in our university, the student feedback is that what they value most about university education is community. How do you address this?
Right, so I probably should have included a few screenshots, but the online courses that we've developed are very primarily focused on the online community of discussing your learning breakdowns with other students. So, so we chose the STEPIC platform partially because of this. Every given step of instruction is its own step on the platform, so it's its own page. And each page can have its own series of comments and solutions that students can submit. So basically, what we've been getting is students from all over the world ask questions that other students taking the class discuss with them and answer. So to put it into perspective, I am the only person that's answering questions as a teaching assistant or as an instructor for all of these courses that have hundreds of thousands of students. So the only way that's feasible is because the students themselves are answering their own questions. So I completely agree that the community setting has to be there, and with the STEPIC platform, we've been able to experience that pretty well.
Thank you very much. Are there any more questions?